So let me show you an example of how we're going to use this limit expression to actually find an equation for the derivative and use that to find the slope at any point. So you're going to be given a function. So in this case, my function is on the left, 3x squared minus 2x plus 4. They could ask you a variety of things. They could ask you simply to find the expression for the derivative, or they could go a step further and say that they want the slope at a particular x value. So I'm going to do both just so you understand the difference between what they're asking. So if they're just asking for an expression for the derivative, you're going to use this limit notation, and you're going to take your limit as h goes to 0, and you're going to put x plus h into this function, so into this function everywhere you see x. So it's going to look like this: x plus h being squared minus 2 times x plus h plus 4. So that is the f of x plus h part. And then you have to do minus the original functions. Let me get rid of this arrow so it's not in my way. These problems tend to get pretty big, so we're not going to do a ton of them. So minus my original function all over h. And basically it turns into a big algebraic mess. You have to multiply it out, distribute, combine like terms, and clean it up as much as possible. So I'm going to first square out the x plus h. This limit is happening the whole time, so I'm not going to write it over and over again. So when I square out the x plus h, I'm going to get x squared plus 2xh plus h squared. That's just foiling out x plus h times x plus h. Minus, I'm going to distribute the 2x minus 2h. And then I'm going to distribute the minus sign in front of the function. So I'm going to get a minus 3x squared, a plus 2x, and a minus 4. And then I can go a step further and distribute this 3 through. So I'm going to do that next. I still have it all over h. So 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 4 minus 3x squared. It's like algebra madness. All of this is over h, and our goal is to get h to go to 0. So let's see what happens. My 3x squared and negative 3x squared cancels. My 2x and negative 2x cancel. The 4 and the negative 4 cancel. So we got a lot of things that cancel, which should happen. The other thing you'll notice is everything in the numerator has an h now. So if we pull an h out, we're left with 6x plus 3h minus 2 over h. That will allow us to cancel an h. If you want to save some time, you could just go through and write down everything in the top and bottom without the h because they all have it. So finally, when that's all said and done, remember that the goal is still to get that h, which is that distance between your x coordinates, to be all the way to 0. And so what happens there is at the very end, you're going to put 0 in anywhere you have h left. And in this case, it's only here. So my final answer is 6x minus 2. This is referred to as the derivative of the function. One of the notations that we're going to use for derivative is we're going to use a prime symbol. So when you see this little prime symbol, f prime of x is how that's read. That means it's the derivative of this function that you were given. Obviously, we're not going to be doing this type of algebra craziness constantly, but it kind of shows you the lengths that you have to go if you do it algebraically. Finally, they could ask you to find the slope at a particular value. So they could either say in words, find the slope when x is 2, find the slope when x is 5, or they could write it like this. They could put that derivative symbol, and then they could put a number into parentheses. What that is saying is, I want to know the slope of the tangent line specifically at 5. And so to answer that, we're going to go to my equation for the derivative. We're going to put a 5 where you see an x. And so you end up with 30 minus 2, which is 28. That is the slope of the tangent line at x equals 5. You could actually graph that parabola, 3x squared minus 2x plus 4, find 5, the coordinate x equals 5, put a point there, draw a line, and that line would have a very steep positive slope of 28. So some terminology that I've been using that I want to make sure I summarize here. What I've been doing is the process of something called differentiation. Differentiation means finding a derivative, finding something that represents the slope of the tangent line. And that's what a derivative is as well. So you see derivative defined as well. Derivative is going to be an equation that represents the slope of the tangent line, and it is found using limits and a whole bunch of algebra using this limit notation. Now, here's the nice thing. On the AP test, they are not going to make you do all of this craziness over and over again. What they're actually going to do is just make sure you recognize this formula. So you will have questions where you'll have to look at it and go, "Hey, that's that limit definition that we learned way back at the very beginning of the class." You're not going to have ones where they're going to do all the algebra we just did because there are so many shortcuts to make this process easier. The symbols for differentiation, I already mentioned the most common one, which is the prime symbol. Sometimes they'll put the prime symbol next to the function name, so f prime of x. Sometimes we'll be really simplistic. Instead of calling it y equals for your original, we'll just call it y prime. The one that we're going to use a lot later in the course, this middle one, the dy over dx, that is the derivative of y in terms of x. That's what that means. The next one with the capital D is usually only used in certain college classes. I've seen it shown up in college. I have not seen it on the AP. And then the last one is sometimes a notation that's used if you have a function that maybe has a different name instead of f or g, maybe it's p or w, where you'll have this little d over dx out front. And what that is saying is I need to derive whatever's in brackets next to it. And then finally, the last thing is we will talk about what it means to be differentiable, meaning capable of even finding a derivative or an equation for a tangent line. And there are certain situations where we know that it is actually not differentiable, which we'll talk about. So that's a nice summary of like how the algebra works and what are some of the words and notations that I will be using throughout this course.